Okay, I'm going to break this into two parts. One where I'm not using calculator and one where I'm going to use a calculator. It's an AP pre-calculus exam designed for high school students to get placement out of pre-calculus when they get to college. So anyway, it says over here, polynomial function p is given by, p of x equals this thing over here. Which of the following statements about n behavior? Well, I'm going to write this n behavior down. I'm going to write it down as a limit as x goes towards infinity of p of x. And that's going towards infinity. And what I got, the leading coefficient is minus 4, so this thing will sail off to minus infinity, because the power of that's 5, by the way. Let me put the limit, the other n behavior is when we go to minus infinity, and that's going to be p of x. And what's that going to be? It's going to be a negative times negative, which is positive, so plus infinity. So I'm looking for those limits. I'm looking for, as you go to infinity, minus infinity. I'm looking for this one over here. And let's see if I see that. I see that here. And I see that, I think it's the only place I see that. I always get confused looking at these things. And what I mean by that is I'm looking at a lot of different information over here. So I'm looking for, as x goes to infinity, that this would go to minus infinity. And I do see that there. The other thing I'm looking for, as you go to minus infinity, I got to make sure it's going to infinity. And it's this one over here. So again, they say over there, sign of the leading term p is negative, and that's what we talked about before. This limit's over here. The degree of the leading term is odd. We also spoke about that as well. So B is the correct answer. All right. Again, multiple choice, you really have to look around. But anyway, just looked. We saw that. All right. Number 2 says the depth of the water in feet at a certain place in a lake is modeled at a function W. I see that and see the picture. They say it's valid between 0 and 30. T is the number of days since the first day of the month. What are the intervals t, which the depth of the water is increasing? I just want to just talk about that increasing here, and it's increasing over here. Now, that's not really their question, though. They say, what intervals on t on which the depth of water is increasing at a decreasing rate? That means it's slowing down, by the way. So what I want to do is talk about, what I'm seeing over here. If I look at this over here, this is increasing, but it looks like it's getting steeper and steeper, so it's an increasing rate. Now, if I look at this over here, this also looks like between 0 and 3, it's increasing, but it's getting steeper. But over here, what I'm noticing is it's increasing, but it appears to be getting less steep as I move up, like we're walking left or right, so it's less steep. So I'm going to say the answer over there would have to be between 3 and 6. What choice is that? Choice A. Let's go to the next one, and this is problem number 3. I'm going to say in this problem over here, and this is me, it might be different for other students or other teachers, but I would be very careful about the factoring of the problem. Let me get back my pen back. It's kind of chunky little thing over there. So I'm going to kind of factor these guys over here. And what I'd say by factoring them is, if they're difficult to factor, I'm not going to factor them, by the way. But they appear to be really simple factorization problems. So like x minus 1, and then x minus 3. Whoops. I think I went too far with that, didn't I? Let me go backwards. So x minus 3. And that would give you x squared minus 4x plus 3. What's the bottom going to be? X minus 1 and x minus 2. That seems to work out okay. You get x squared minus 3x plus 2. Good. Let's go to the next one, x minus 3. And then it looks like x minus 2. And what's the bottom going to be? X minus 2. And it looks like x minus 1. Let me just recheck that. Yeah, you have minus 3x. Yeah, it looks pretty good. Minus 5, 6. Yeah, it looks pretty good. This one's pretty easy. Just x minus 3 on top there. Let's go to the bottom. X and x again. And it looks like 2 and 1 minus minus. That works out beautifully. X minus 3. Again, you get x and x. Relatively very simple factorizations. 3 and 1 minus minus. So what does it say? Which of the following has a 0 at 3? So this one does. This one does. And that one does. This one doesn't. And the reason for that, there's a removable discontinuity here. So this is out of the question. All right, let's go to the next one. So it says over here, vertical asymptote at 2. Well, this one has a vertical asymptote at 2, but this one does not. And the reason for that, there's a removable discontinuity there. So this one gets thrown out. But this one's got a vertical asymptote at x equals 2. But then they go on to say it also has a hole at 1. What does that mean? A removable discontinuity there. So this one would do it for us. All right, so I'm going to say it's letter A. All right, that one's done. Let's go to number 4 now. Number 4 says polynomial p, odd function, At 3, it's going to be minus 4. If it's odd, there'll be a point over here, which would be minus 3 plus 4. Odd means it's symmetric with respect to the origin. It goes on to say there's a relative maximum of p at that point, which is 3 minus 4. What does it mean over here? There'd be a relative minimum at this point. Well, let's see what the choices are. That p of minus 3 would be equal to 4. Certainly that's satisfied. This is no good. P minus 3 is 4. That's satisfied. And this one is out of the question. So I got my choices now. Letter A says it's a relative maximum. This is not a maximum. It would be a relative minimum. So the only clear choice over here would be choice letter C. All right? Let's keep going. And I'll look the next one down. And the next one says, that you're given a function g, and I read that. It's a polynomial cubic. And a function h given. I see the h is quadratic. It says k is a ratio of those two. And this says, what is the domain? Well, the domain of these things it's a rational function. I can't let g be 0. So let's write this down. G of x is equal to 0. When does that occur? I don't know. So we get x cubed minus 3x squared. This can't happen, by the way. If this happens, this is not in the domain of the problem. So 0. I'm going to factor an x out. You get x squared minus 3x minus 18. 0, x. Let's see, x and x. I'm going to say 6 and 3. It looks pretty obvious. Minus 6 plus 3. So x can't be 0. X can't be minus 3. And x can't be the number 6. But it can be any real number, by the way, except for those numbers. Let's just take a look at it. And we'll look for that answer. And we're looking for all the real numbers. They all say that. But I'm looking for those ones that say, don't allow 0, don't allow minus 3, and don't allow 6. And that appears to be C. Right? C, I can't let minus 3 in, can't let 0 in, and I can't let 6 in. So that's number, was that number 5? Yeah, number 5. I'm sorry. I get confused sometimes what number I'm on. I'm going to go to number 6 now. All right, number 6. They're kind of complicated questions over here, but I noticed that they're giving me a picture of G, and they're asking me which one could it be. And there's no numbers here, but I do know something about this over here. I know there's 2 positive roots, and that means I'm going to have numbers like, x, if it's a positive, like x minus some number, a positive number, x minus some positive number. And I also know something over here is it's a repeated root, so there'll be a square there, all right? So I want to kind of look around. I want to see if I see that with, x minus a number. And, looking at these numbers over here, it looks like they're using 1 and 5. So I'm going to put 1 and 5 over here. That looks reasonable to me. So I'm going to look for x minus 1 and, up to the first power. So I'm going to say this one looks like a good candidate at this point over here. And the other one I look at is the this over here. Now, again, if this is, minus 5, that's certainly much greater. So that would be x plus 8 then. All right? And I do see that. That's letter C. Okay, that's done. All right, let's go to the next question, which is going to be problem number 7. And number 7, let's take a look at it. I think it's a table problem. That's my recollection. The table of values of polynomial f is given by blah, 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 blah. And then they say it's like this transformation. And I know it's difficult, but it says that g of x is equal to a times f b of x plus c, where a, b, and c are positive constants in the xy plane. The graph of g is constructed by 3 transformations of the graph of f in this order. Now, horizontal dilation, and dilation means it's getting wider. All right, so I'm going to say if it's a horizontal dilation, it's going to be f of, and I want to make sure I understand what they said, horizontal, a factor of 2. So that's going to be 1/2 of an x. All right, so I got that part covered. So it says, I'm constructing with the transformation, by the way. So applying the 3 transformation, horizontal dilation by a factor 2, and a vertical dilation, that means it's being stretched vertically by a factor of 3. I'll put this over here. And then it says over here, it says there's also been a vertical translation of 5 units. That means it's been moved up 5 units. And this is what g is going to be equal to. So we're going to write down g of, let's see what they want. They want g of minus 4, right? Let's see if we can do that. 3 times f, well, that would be minus 2 plus 5. Do you know what f of minus 2 is? Well, let's look in the table f of minus 2 is the number 5. So you get 3 times 5 plus 5, which is 15 plus 5, which is 20. Let's look and hope we see that, and we do. And that's going to be choice D. All right, let's go to number 8. Number 8's a log problem. Looks pretty relatively simple. They tell me that K, W, and Z are all positive numbers. So I can expand this guy. How would you do that? It's going to be log base 10 of KZ. That's a product. We'll split that up momentarily. Plus log base 10 of W squared. Well, I can take the first term. It's a log of a product, and write it as log of a sum. And this power rule, I'm going to bring it, whoops, sorry about that, I didn't mean to do that. The power rule, I'm just going to take the 2 down, plus 2 log base 2, 10, sorry about that, W. Okay, let's look at the multiple choice to see if we see that. Am I seeing that? And I'm seeing that somewhere. You know what? I made a mistake. And I just realized I made a mistake looking at the K. And the mistake was, I'll point it out to you, and I'm glad I have a multiple choice test because I really could correct myself. This is not a plus sign. That's a negative sign. Sorry about that. Again, it's a quotient, so it's a subtraction. So let me just take a look again, make sure I did it right. KZ minus K. Yep, looks good. Let's take a look at it and see if I see that. And am I seeing that somewhere? Yeah, I am. Where am I seeing that? It's choice B. All right, let's do this one over here. And looking at it, it says, I see the graph, by the way. It says it's a graph of a geometric sequence. So I'm going to write down what I'm seeing is, the A1. It looks like that's 8. And then I'm going to say, if it's geometric, there's going to be some common multiple. I'm going to call it R. And it looks like each time it's being halved. So then I'm going to write down AN is going to equal 8 times 1/2 to the n minus 1. All right? So let's take a look at it. Do I see that there? And unfortunately, I don't see that. All right? So then I got to start thinking, what am I going to do about that? Seeing things that are clearly not the case, like I'm going to say this is out of the question, this is out of the question, and this one, I got the last two. Let me take a look at that. So AN, I'm going to write this as 8, I'm going to write as 1/2, and then I'm going to put down n minus 2 here, and then what would I put over here? I'd put 1/2 here, and that's to the first power. And would that give me n minus 1? It would. And what do I get over there? Well, looking at that, AN, half of 8 is 4, and what do you get there? 1/2 n minus 2. What choice is that? That's choice A. All right? So let me see if that looks all right. We got that one. That's A. Let me go on. All right, let's keep going. And number 10, I'm looking at it. It says the table of values of a given function g for selected values of x. The function f is given by find the value of f of g of 3. Well, let's write this down. F of g of 3. This is a composition, by the way. So it's going to be f and g of 3. Well, looking at it, g of 3 is going to be minus 2. Now, what does f do to its argument? It's going to be 3 to the minus 2 plus minus 2 squared. Well, let's write that down. That's 1/9 plus 4. I don't see that answer, by the way. So I'm going to say they probably combine the two numbers together. That's 9, and 1 plus 36, which can be 37 over 9. Is that answer there? Yeah, it's letter B. All right, let's keep going. And the next one, we don't cover this at in college, by the way, but just kind of looking at it, and they say this is they're trying to fit a linear line to this thing over here. But I want to point out, that just doesn't seem reasonable. If you look at this pattern over here, I mean, these are definitely following a quadratic pattern. So I'm going to say over here, just reading the food vendor trying to develop a new sandwich type of sale. The vendor made estimates, blah, blah, blah. Linear regression was used to develop a model for sales over time. The figure shows the graph of the residuals of the linear regression. Which of the following statement about the linear regression is true? I'm going to say the linear model is not appropriate at this point because I'm looking at that. It does look quadratic to me. It looks like really a quadratic model would be fit. So I'm going to say the linear model is not appropriate. So I'm going to say, looking at it, I'm going to look at A and B as being the possibles now. I'm going to say C is probably not a good idea and D is probably not a good idea. Now, what I'm going to say, the linear model is not appropriate because there's a clear pattern in the graph of the residuals. All right, so that's one choice. Let's look at the other one. The linear model is not appropriate because the graph of the residuals has more. No, that's not true. So it's got to be A. All right, let's go to problem number 12. And 12, I often get confused reading these problems over here because they're using things about quarter years and things like that. But it says the value in millions of dollars of transaction processed by an online payment platform is modeled with a function m. So I'm going to say m is some function of time. All right. So the value is expected to increase by 6.1% each quarter of the year. So at t equals 0, the amount is 54. And then it's going to be 1 plus, well, I'm going to put the percent down as 0.061. And this is happening, 4 times a year, by the way. So I'm wondering what they're talking about. And they're talking about years now. So time t is in years. So it says if t is measured in years, which of the following is expected? Well, I got to put the exponent down now. And the exponent, looking at it, is going to be 4, because this happens 4 times a year, by the way, 4t. Let me see if I see that answer, and I'm not seeing it. So I'll write this over here, 54. I'll add the terms together. It's going to be 1.0614t. All right? Do I see that? I do, and it's the last one. It's letter D. All right, 54, 1.061 to 4t. All right, iodine, half-life, 8 days, a particular sample amount, blah, blah, blah. They give me the formula of it. I see that written down, where A naught is the amount of iodine, blah, 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 at the time D equals 0, and D is in days. Which of the following function models K, the amount of iodine remaining? Oh, now they're talking hours. So the model they've given me is A naught, and then it's going to be 0.5, and then it's going to be D in days over 8. But now they're talking about T in hours, right? D's in days, right? So I'm going to put this down. It's going to be A naught, and it's going to be 0.5. And then I'm going to say, T is in hours now. So I have to figure this out. And what's that going to be? Well, if there's 8 days, how many hours in a day? 24, right? So it's 24 times 8. I don't see that listed. So I'm going to keep rewriting it. And you get 0.5. And then let's take a look at that. And I'm going to start crossing things out that can't be. This can't be right. Let me see, B. Now, B can't be right. I don't know, C. Look at C, right? And then we get T. No, that's not right either. And so I'm going to say this is not good either. And by the way, I'm looking at this 24 times 8, and I'm starting to realize this is T. That's 160 and 32, which is 192. All right? So what is it going to be? It's really, and they just rewrote it over here, A naught, and they wrote it as 0.5 to 1 over 192. I don't appreciate they did that, by the way, raised to the power of T. I'd rather they had the answer written this way over here. But that's why they wrote it, same answer, and that's going to be choice D now. All right, let's put this one down. It says, what are the values of x for which this equation is true? Let's write this down. So you get natural log. This is a difference, so it's going to be x cubed over x is equal to 4. So this is going to be x squared, that's ln, equals 4. And then x squared is going to equal e to the 4th power. All right? Then if you wrote this down, you'd say x equals plus or minus now. Use square root rule. And it's going to be, half of 4 is 2, so e squared. The thing about this over here is that I can't use a negative number because the argument for logs have to be non-negative, so for this real number system. So x has to be e squared. Let's look at this over here and see if I see that. And I think it's, they only have one choice there. It fits that description, this one over here. So it's going to be choice letter C. All right, let's keep going. Let's go to 15 now. And again, it's a multiple choice exam. They're not looking at your work, by the way. So this one, it says, let f of x equal 1 plus 3 secant x, let g of x equal minus 5 in the xy plane. What are the x coordinates? Well, I'm going to write this down as an equation then. So it's 1 plus 3 secant of x equals minus 5. I'm saying when do they intersect each other? When do they equal each other? And it's going to be 3 secant of x equals minus 6. And then I'm going to say secant of x equals minus 2. Now I'm going to turn it into cosines because it's easier for me. Cosine of x would be equal to minus 1/2. And by the way, I got to stick between these two numbers. So what I would do is I'd look at the cosine curve now. And the cosine curve looks like this over here. And I know I'm between certain values to get to minus 1/2. And those values, I'm going to put in degrees, by the way. This is 90 degrees. And over here, this is 180 degrees. And over here is 270 degrees. I'll go to radian later, by the way. So, what's the reference triangle, by the way? I'll put this over here, the reference angle. And it's going to be the ratio would be 1. This is 2. This is root 3. So the reference angle is 60 degrees, by the way. So what's the angle between 0 and 180 as a reference to 60? 120. And when you go between 180 and 270, what's the reference there? 60. So it's going 180 plus 60, which is 240. Now, certainly those numbers are not being listed. They're listing radian measure for a good reason. I got to write that down. And so I'm looking really at pi over, there are multiples of pi over 3, 60 degrees. All right, that's what they're looking for. So the first one's going to be 2 pi over 3. And the second one's going to be 4 pi over 3. Do I see those answers? Let me take a look. Do I see 2 pi over 3? I do, and 4 pi over 3, and that's choice C. All right, that one's done. Let's go to 16. 16 gives me a picture. Let me get rid of my chicken scratch over here. I don't need it anymore. And let's take a look at it. It says the graph sinusoidal function g. I see that. What are the values of the period and amplitude? Well, what I'm going to do over here is I'm going to look at one cycle of it. I'm going to start there and stop there. And the cycle length over there, the period, is 9 minus 1. So the period is equal to 8, which is 9 minus 1. The amplitude of it is half the distance between the trough. And what's that going to be? It looks like it's 3 up, 3 down, so 3 units. So the amplitude is going to be 3. Let's look for that. A period of 8 and an amplitude of 3. And I do see that right over here. That's good news. Let's keep going. We're going to 17. And 17 is a polar graph. All right? So the problem with polar graphs is, you might say, I just memorize these things over here. I'm not saying it's a bad idea. I'm just going to say I'm going to look at it. And what I want to do is I want to start looking at, behavior of the graph over here. And the first thing I do, I'm going to start with thetas, and I want to find out what the r is being produced, all right? The r is actually the function of theta. It's the radius of the problem, and it's a directed distance from the pole. So I would start at 0. And what would 0 give me? It would give me 5. So right now, I'm going to say this one's out of the question. This one's out of the question. This one's okay, and that one's okay. But I still want to go. I want to go further. Someone says, where are you going to go now? Well, I'm not going to go to a number that's difficult for me to compute. I'm just going to go to pi over 2. And if I go to pi over 2, my question is, where would I go? So the cosine of pi over 2 is 0. So I'd go to 2. All right? So what I want to do, let me make sure I did that right, by the way. Pi over 2 is 0. Yeah, I go to 2. So let me see if that's true. I'm going to these guys over here. Well, you know what? I see the 5 there. I see the 2 there. I definitely see that. I see the 5. I see the 2. So both of these are still in the running. So let's keep moving. Let's see what happens next. Where would I go next? I'd probably go to pi. All right? And let's see what happens at pi. Well, the cosine of pi is minus 1. Right. So you get minus 3 plus 2, which is minus 1. So what I want to do, I want to see which one of those graphs does that for me. Right now, pi is over here, and I'm expecting to go in the other direction, and I don't see that there. So this one's out of the question. I see it here, though. So this is the one's happening. Now, what's happening to this graph over here? Let me get my rent thing out. It's going like this over here. And then what's happening? It's doing something like this over here. So D is the correct answer. So I'm going to circle the D now. Right, D is the correct answer. So let me see if there's more questions. I got to turn my paper myself. And, oh yeah, there's 2 more. There's 19 questions to do. All right, so let me look at this one over here. And it's problematic, but I do want to write down why it's problematic. I'm reading it, and they're between minus pi and pi. Let's not worry so much about that. But what I want to do, I want to talk about one thing at a time. And the thing I want to talk about is this guy over here. So I'm going to say cosine of theta is going to be greater than minus 1/2. What I do, I divided both sides by 2. And all I want to do is kind of look at the cosine curve, and the cosine curve looks like this over here. And this is going to be pi, and this is going to be minus pi over here. All right? And it says it's greater than minus 1/2. I'm kind of looking at that, so I'm going to say, it's this section of the curve. Well, that doesn't look too bad. Let's get the reference angle for that. I know we just did it, but let me just point out the reference for this thing over here. It's going to be a triangle, 1, 2, root 3, which is 60 degrees. All right, I'll go to radian later, by the way. So where does this occur between? For this one to happen, it would have to be between minus 60 and, you know what? I'm sorry, I misspoke there. And the reason for that, this is 90 degrees over here. It's actually, I misspoke. I got to correct that. My bad picture, I should say. So what do you get over here? It's 90 plus 60, which is going to be, did I say that right? 60 degrees. I'm getting a little tired right now. And 1/2 for cosine, that would be 60. Make sure that's true. Yeah, that's true. So let's see. 60 would push this into the. Let's write this over here. It's between. I got discombobulated over there. So it's 90, and I got to go. Let's see. It's going to be 180 minus 60, 120. Put that down to 120. All right, that's done. Let's do the next one, and it's going to be the sine of theta is going to be greater than root 3 over 2. Well, isn't that convenient? That's still going to be a 60-degree triangle. Let me get a better picture here of the sine function. And the sine function, it looks like this over here. All right? So, and again, I got to stick between minus pi and pi. Well, you know what? That's right over here. So I have to look at that again, and I'm looking at what the theta is for that. And the theta, well, if I thought about that, it's going to be 60 degrees. That's the reference. And then it's going to go into that, between 90 and 180 with the reference of 60, which would be 120 degrees. Now, by the way, it has to meet both conditions. So really what it's asking for the intersection between those two sets. And the intersection between those sets, it appears that it's intersecting between 60 and 120 degrees. So what's that going to be? Pi over 3, theta, and this is going to be 2 pi over 3. Let's see if that answer is being listed. And I'm looking for it, and I do see it. It's right over here. That's letter D. All right? So let's look at this one. I think it's number 19, and it says a polar function is given by this thing. And it says, as theta increases on the interval between 0 and pi over 2. Well, you know what? I'm going to do that. I'm going to look at what happens. So I'm going to start with theta, and I want to go to r, where r is a function of theta. All right? So we'll start at 0. I'll see what happens at 0. Well, at 0, what do you get? You get minus 1. So what does it mean? You go to the angle, which is 0, but you go in the opposite direction. So it's over here. It's where it's starting, by the way. And now when I go to pi over 2, you must say it's a big jump, by the way, but I'm wondering what happens when I get to pi over 2. Now I want to put pi over 2 is over here, all right? And I want to say there's something happening. So when you get to pi over 2, what do you get? You would get the 0. So I hope you realize that over here, we're actually going through negative numbers here. So as I move in this direction over here, all these numbers are going to be below the x-axis like this over here. Then they eventually come back to the 0. All right? So let's read these things, what they're giving me. It says the points in the graph are above the x-axis. That's not true. The points in the graph are above the x-axis. That's not true. They're below the x-axis. The points on the graph are below the x-axis. Well, this one's possible. And are getting closer to the origin. That's certainly true. All right, let's go to the next one, see what happens over there. Points to the graph are below the x-axis and are getting, no, that's not true. So C is the only choice, all right? So I'm going to say we're done with this section of the exam. I know it was a difficult section for a lot of students, and I don't like multiple choice exams either, and I don't like being timed either. But the next part is going to be using a graphic calculator, and we'll get to that. Thank you.